Okay, now grade 7. This is about types of waves that we have been using a lot in our daily life, which is electromagnetic waves. Now, electromagnetic waves are transverse waves, which means they go up and down. Now, it's basically, why do we call them electromagnetic? Because they change the electrical magnetic fields at right angles. Doesn't matter very much to see how that works. We just need to know their properties. However, why do we call them electromagnetic? Because they are made of two parts. One part is electric, the other part is magnetic. Now, once they change, the electric part and the magnetic part will be at right angles from each other as the wave is traveling. Now, there is a spectrum for that, which means they start at a certain point and end at a certain point. However, they all share all the same three properties. They transfer energy as radiation, which means something you can feel. You can't see, but you can feel, sort of. Now, they can't go through vacuum. Unlike the longitudinal wave, these can travel even if there's no matter. And they are pretty fast. They travel at 300 million meters per second through a vacuum. However, some of them is short wavelength, some of them have long wavelength. Now, the shorter wavelengths have more waves moving through a point, so they have high frequency. The longer wavelengths have less waves passing through a point, so we say they have low frequency and they have low energy also. So the ones with high frequency have high energy, while the ones with low frequency has low energy, which affects the ability to do work. Now, the type or the spectrum or the type of waves actually range from or are arranged according to wavelength and frequency. The ones with the longer wave are placed here. The ones with the shortest waves are placed here. Now, you can see we have different types, and these types have, some of them we are very familiar with, like visible light. I'm sure you are also familiar with microwave waves, and what else? Maybe X-rays, I'm sure you heard of that. What else? Pretty much, maybe gamma ray is new for you. Now, gamma ray is sort of an atomic rays. We're gonna discuss that in atomic decay, the next chapter, which will talk about a lot of on the source of gamma ray. However, the rest you might be very familiar with, starting with radio waves at the highest wavelength and the lowest frequency, ending with gamma rays at the highest frequency but the shortest wavelength. Now, basically, each group contains a range of frequencies. For example, light, visible light contains frequencies that we can see. In other words, you can see. You may feel them, but you cannot see them. For example, red light has the lowest frequencies and the longer wave. And violet light has the highest frequency and the shortest waves of the ones we can detect using our eyes. Now, what do we use them for? Basically, radio waves, long, so we use them to carry waves of frequent or waves of speech as radios. These are the ones we use in telecommunications, like television, radio, and your mobile phones also. Now, microwaves are a bit shorter, however, they do carry high energy, higher than the radio waves. That's why we use them for cooking food and satellite communications, because they can be more precise and more accurate than radio waves. Infrared is the one just before that. That's we call it infrared. It's basically it has a shorter wave, therefore higher energy, and this is basically the heat energy you use. No, the red light is not heat energy. The red light is light. Now, however, it does come around with infrared, and that's basically the heat or the waves that carry heat around from one place into another. And also, some organisms like snakes, they can use infrared to detect objects in the dark. So they recognize you as a source of heat, and therefore they can see you or detect you even if it's dark. Not much of a survival chance for you, but good survival chance for snakes, especially the ones who hunt in the dark or in caves or wherever. Okay, visible light is the rainbow light. It's the light you can detect using our eyes, having the longer wave for red, the shorter wave for purple, and the rest come in between. And basically, this is the visible light your eye can detect. Now, the ones that are not within the visible light range, you cannot see. You can feel, but you cannot see. Okay, basically we can use them in optic fibers, coded pulses, meaning the signals you can use like on and off using a light torch or something. Ultraviolet. Now, ultraviolet comes here actually. It's beyond violet. It has very high frequency. It's also unfortunately have hazardous effect on you because if you stand in the sun for a long time, you get a little bit extra of ultraviolet light, which actually burns your skin if you stay for a long time. That's not very good because that also can cause your skin cells to mutate and sometimes, unfortunately, turn into cancer cells. However, ultraviolet has a higher frequency, so it's used in different fields, like for example, sterilizing, meaning killing microorganisms in water and vegetables without affecting the water properties or vegetable properties. Also, some ultraviolet can be used in fluorescent object and they can like shine in the dark without actually using heat. I'm sure you're familiar with many fluorescent objects where you put in the dark and they glow when you put the light off. Pretty much like these fluorescent um, knobs. Or used in the bash, used in birthday parties sometimes. Now, the other types are going to be discussed in the coming video. And here we stop now. If you have any questions, please email me. Please concentrate on the main ideas, not to go into too much details. We just need the main idea for each of these scientific concepts that we discuss. See you.